Welcome one, welcome all. I'm very excited today because if anyone has listened to one of these streams previously, then you know that the audio was not good. And that's because I was using a headset of mine that I got from my office when I used to be at the office before the pandemic started. I don't even know if I should say pandemic anymore because it's not really a big deal, but hopefully now on stream, my voice sounds a lot better. This is the first time in my life that I own an actual microphone to do any sort of streaming, so I'm very excited for that. My cutoff was to get to 50 questions before getting myself a mic. You can see we're at 49, so we're almost there. Hopefully, we'll pass that threshold today. But I'm really hoping that this makes it easier for the viewers. It should make it nicer for me to even listen back to my own recording before uploading this to YouTube. And it's just a very exciting time for me. So I hope, again, that you all enjoy the stream. And let me do some quick housekeeping before we get started. So for anyone that's watching the stream today, maybe for the first time, or has kept up with me in the previous days, you already know that I have been uploading all of these streams onto YouTube. And in the YouTube channel, which I will now link to the stream chat, in the YouTube channel, I have a sort of like channel introduction that viewers can watch to get an idea of what my channel's for. At a high level, it's really for people to get involved with LeetCode, to go from having done no questions to having done some amount of questions. If you've been following along with me, I started last Saturday, so this is one whole week I've been doing this. We would all be now at around 49 questions. And hopefully along the way, you would have learned some things. So, the channel has evolved since then. I've been taking all the feedback that I can get and trying to get better. And some things of note that I want to say are, for example, now on videos, the chapters we always had. Well, chapters are something new that came up, so it's easy for you to navigate the video and then click on a problem. I also linked to all the different questions that we solved. And I think for like the latest one, something else I did, I need to go back and add the chapters to this one. But something I did for the latest one here is I also added some links to some of the articles that we look into. And the reason I did this is because I tend to use maybe some methods from JavaScript or maybe some other sort of computer science fundamentals of things that I know that I want to explain, and I like to link to resources when applicable. So yeah, very happy with that. I can't wait to upload this stream to just appreciate the quality of the audio. I'll link to the gear that I have. Right now, the only mic that I have is just I bought myself the Blue Yeti USB microphone, and I'll link to that in the description in case anyone wants to know. And I pretty much just did a plug and play, and that's all I really had to do. So anyway, long introduction, a lot of housekeeping, but just wanted to get that out of the way. Really excited for this new chapter. 50 questions. I'll make this the first milestone. So let's just start from here. Yesterday I did a stream sort of late at night, and I was getting a little bit tired, but the one that I sort of ended on was this one right here, count good triplets, which if you see, it's not, people generally don't like this question. It's a very the like to dislike ratio is like terrible, right? But after just sort of like thinking about it, I think, and maybe there's a good way to do it, but because it's such a low quality question, I didn't want to spend too much time discussing it, and I'll sort of just explain my solution this time. So what I did was, I have a function here that I defined called isGoodTriplet that really just takes exactly what they told us about here and codifies it. So it's just a function that checks to see if given 3 indices, if they form a good triplet within the array. And all I do is a brute force throughout the entire array and get every single triplet, and I match it against isGoodTriplet. And anytime there's a match, anytime this function returns true, I increase the amount of pairs. So we can submit this now. We see that the time complexity is okay. We know it's going to be cubic, right? Because we have the 3 nested loops. Sometimes this comes out, higher than other times, but like I said, I'm not going to spend too much time on this. Probably in the chapters, I'll still link to this question because it is still the first one that we're looking at today. So I think that's worth it. But let's go ahead and continue on to the next one. I think count equal and divisible pairs in an array. I think this one we were looking at yesterday. Yeah, I actually wanted to get back to this one instead of starting off the stream with this. since this is a more tricky one, I think I'd rather start the stream off by maybe visiting some other ones, seeing if we can make some progress, and then we can revisit this one at the end. So let's go ahead and start with this unique Morse code words. Again, this doesn't really have a good like to dislike ratio, but let's see what this question is asking us about. So International Morse code defines a standard encoding where each letter is mapped to a series of dots and dashes as follows. A maps to this, B maps to this, and so on. And they give us essentially like the alphabet, right? So given an array of string words where each word can be written as a concatenation of the Morse code of each letter, for example, cab can be written as this, return the number of different transformations among all the words that we have. Okay, so I think what we can do is for every single word, we will generate the Morse code for it, and then we will add it to a set, and then at the end, the size of that set will be the answer. So let's copy our Morse code alphabet right here, and I'll label that as such, const Morse code alphabet. I tried making sure that the microphone wasn't too loud, like against the keyboard, so hopefully that's the same for anyone that's listening in. Now what we need to do is we can go through each one of the different words, right? So let's come over here, and now let's say for const word of words, let Morse, or we can say let Morse code word. Maybe we can make this an array. And now we can say for const character, we'll say for const car of word. Now what we can do here is we can get the index of the character we're currently at, and that's going to help us index into this alphabet, and that will give us the string that we can append to Morse code word. So we can do something like const index equals car dot car code at 0. We'll do a -97 because I think everything here is lowercase English letters. So the -97 is a decimal value of lowercase a for ASCII. So if we're given a lowercase a, we can do a -97, and that will give us 0, which will coordinate with this first one right here. So now we can say Morse code word dot push, and then we'll get the thing at Morse code alphabet at that index. And then at the end, we can say Morse unique Morse equals new set. Every time that we finish this, we can say unique Morse dot add. We can say Morse code word dot join. And then at the end, we should just be able to return unique Morse dot size. And I think that's just a property, an instance property. So we should just be able to use it like this. So that's 2 and 2. Got to wait a couple of seconds here. Still have to wait a little bit longer. 2 and 1. So if we submit this, let's see what we get. Okay, 85.16. Pretty happy with that time. 13.10. 49.71. So I'm just submitting to get like an average to see what we end up with. So I'm pretty happy with this. I mean, we are going through all the words and then each individual word. So that's going to be m times n for time complexity. And anytime we add something to our set, it pretty much happens in constant time. I think V8, the Chrome engine V8 uses an ordered hash set underneath the hood, which I believe amortized time for that is constant. So for insertions. So because of that, this really is m by n, and the space complexity will be, I guess, u, where u represents the unique words found inside of words, the unique Morse code representations of each one of those different words. Easy and concise solution. They're adding this to a hash set and returning the size. So pretty much exactly what we did. So there you go. That gives us our 50 questions. So that's awesome. That's like a major milestone for myself, for anyone that's been watching on this journey to do all the easies. We will follow up on all the mediums and all the hards, but I mean, we are making some progress. And so we're just going to keep going, right? We're like I don't know, 10% or something of the way. So let us go to another one. The one after this one is flipping an image. Given an m by n binary matrix image, flip the image horizontally, then invert it and return the resulting image. To flip an image horizontally means that each row of the image is reversed. 110 horizontally results in 011. To invert an image means that each 0 is replaced by 1 and each 1 is replaced by 0. I mean, I feel like there's maybe it's a naive solution, but a brute force solution would be just to go through each array inside and then do this operation, right? And we might be able to use some nice JavaScript to be able to do that. So what if we returned, we can do image.map. Inside of here, we get our inner image. And let's see. Well, the inner image is a single array, right? So we still actually need to, we should actually return. Let's do this. Let's do array. Yeah, let's do array.map inner image. And then for each one of these, can we do, I don't know, like, what if I do inner image? This is going to go over this one. This is going to give me back this one. Maybe here, actually what I should do is reverse it. That will reverse it. And then this will just give me back. Now can I just do each individual one? Is this like a way that we can do it? Or perhaps I should actually go, maybe there's actually a different way there might be a different way that I want to do this. Let's actually do for const inner image of image. So inner image, let's not do let inner image equals inner image dot reverse, and then inner image equals inner image dot map. And then here, let's say we get like a bit is equal to 0, return 1, else 0. Return image. So will this work? I'm just curious if like I even have to, yeah, I guess this is not actually doing let inner image of image, inner image equals inner image dot reverse, and then inner image equals inner image dot map. I think we have to do all these at once instead of just, so let me do this. If I write our input out here, when I map over this, the thing I get in my first map is just going to be one of these arrays, right? Return image dot map of inner image. Now, what do I want to do with each one of these inner images? The inner image in here, I want to say return inner image dot reverse dot map bit, and I think here we can do this. So let me actually delete all this, see what this does. I believe that reverse 1000, okay, so this looks like that worked, or it looks like this worked. Just doing a quick look here, everything's looking all right. Okay, so it doesn't look like it's the fastest way just based on these numbers. Again, let's submit this. 46.34. It got a little bit better, but it wasn't such a significant difference that I think this is actually the way to do it. If I had to take a guess, for some reason I feel like bit manipulation might be the way to go, but let's see the solution. So we can do this in place. In each row, the ith value from the left is equal to the inverse of the ith value. We use c plus 1 divided by 2 with floor division to iterate over all indices I, including the center. Whoa. using built-in list manipulation tool. Reverse for each synthetized complexity be O of n squared. It will be at least O(n) times m for, I think it can be easily be solved in JavaScript in the next way. Image reverse map. So I'm curious, what is, for anyone that's watching, what do you all think? Is something like this better for an interview? Would maybe they expect for me to come up with something more complex like this, or is using something like this okay? I almost feel like this is okay because it shows that I have a grasp on some of these constructs that the language provides for me and I know how to use them. And I'm doing something that is a little more practical. Like I would expect to see a solution like this in, you know, a startup or enterprise code base. And if I saw something like this, if I saw something like this in a pull request, I might suggest for them to use some of these other methods, these higher order functions. So very curious to see what you guys have to think. When you think about doing something, you know, imperative versus declarative, do you choose one or the other? Yeah, let me know. Would love to hear what you guys have to say. All right, so on to the next one. Remove outer parentheses. A valid parentheses string is either empty or a plus b. This is a lot of a lot of text. What is it that they want me to do? Remove the outermost parentheses. Is there a way that I can get, let's see something. Let me get my I here. Like, let's say I is 0 to begin with. This is open, so I increase that to 1. I'm going to have a counter. So this is 1. I see another open, so that's 2. I see a close, so that's 1. I see another open, so that's 2. See a close, that's 1. I see a close, that's 0. So maybe when I get to 0, now I know, like, based on this being 0 and where I started, I know that these two things are my sort of like closed parentheses. So maybe I should, let's think about this. Is there a way that I can just add this to a set? Can I add the indices of where this is 0 to my set? So if it's 0, I add to my set. So maybe I can say something like 1, if count is 0, add to set, and then increment / decrement count based on character. And when I say character, I mean parentheses. So let's say we have a set. Here we're at 0, counts is 0, so let's add the index to our set. Now we come here, it's 1. Or rather, no, it's 0, we add to set, and it's open, so we do 1, that's 2, that's 1, that's 2, that's 1. I come here. If it's closed, yeah, I guess it's going to be, if count is 0, we add it to the set, increment or decrement count based on the character. If I'm currently on an opening, yeah, maybe we can amend this to say if count is 0 and I am at this one, or if count is, let's see, 1 2 1 2 1 0. If count is 0 and I am at close, because I wouldn't want to, yeah, count would be 1 here. Be 1 2 1 2 1 0. Yeah, I guess we should. Yeah, I don't want. The thing is, I'm trying to figure out, like, when do I increment first before adding to the set? In this case, I should add to the set before incrementing. Add to set because it's 0 and an open. Add to set because 0 and open. 1 2 1 2 1 0. So add to set because close and 1. So maybe we can do something like this, and then I do my decrement or increment. So let me see how we can do this. So I'll do for const p, where p represents the parentheses, of s. Let's see, if count. So if count is equal to 0 and c is equal to open, maybe we can add this here. Add to set because close and 1. Or I can also do if count equals 0 and c equals closed, or count is equal to 1 and c is equal to close. Maybe this could be enough for me to add it to my set. And I'll say I'll have a set of indices. Oh, but I'm gonna need to, yeah. Let I equals 0, I less than s dot length, I plus plus, const p equals s at I. Let's make both of these into p. Here I can say indices dot add I. And then let's do our count. Let count equals 0. So if p is equal to open, counts plus plus, else counts minus minus. I'm gonna run through this again to see what we get. So if we're starting again at the top, what do we say, right? This is gonna be my set, this is gonna be my count. So if count is 0 and p is open, so that's true, we can add 0. And now if p is equal to open, we do this. If it's open, if count is 0 and p equals open, it's not the case. It's also not 1 and p closed. So if it's open, we just add to count. So now we'll add this to count. So p, if count is 0 and p, okay, none of these are ever going to happen, right? Count is not open, so we reduce this to 1. If it's 1 and closed, nope, but it is open. Now we go here. Count is 0. No, it's 2, but it's closed. Okay. Now we come here. So it's count is 1 and p is closed. So let's add this index 0, 1, 2, 3, 4, 5. Let's add 5. And we can decrement the count. So now we're at 0. Now we're here. If we're at 0 and it's open, we add 6. And since it's open, we go 1. Come here, we add 2. Come here, oh, the I is here. Count is 2. No, we can just decrement this. Okay. We're here, it's closed and it's 1. We add the 7, which is the one right at the end. And then we exit out of our bounds here. I think maybe this can work. Kind of just want to give it a shot like this. We went through one example ourselves. Let's comment all this out. And let's go through our example here. What I'm planning on doing now is at the end when I have my set. Let's see. I think what I can do is const result for let I equals 0, I less than s dot length, I plus plus. If indices dot has I, then we can just continue. Else, to our result, we can just push the parentheses at s at I. And then finally, we'll return result dot join. Let's see what this gives us. Okay, it worked for that first example. Looks like it worked for all the examples, so let's run this and see what we get. Oh, very nice. That's great. 87.72. So I'm pretty happy with this. Like, again, something that I've been doing a lot of is just taking the time to design the algorithm before jumping straight into the code. And this can help you whether it be for LeetCode, system design, your day-to-day software engineering work. If you just take the couple of minutes, like just a little bit of time to design it, it will save you so much time at the end. You notice that, like, I promise you this question, haven't been able to solve it before. Literally, I remember watching this question, not being able to do it, and I never even did this. But I think this is one of those things that the stream really helped me do because I'm forced to have to talk. Like, I'm not just going to make a stream of me being quiet, right? It forced me to talk. It forced me to design an algorithm out. So I highly encourage the listeners to do the same. Design your algorithm, get a good feel for it, and then go ahead and implement it. Let's see what the discussion says here. Count open parentheses. So I'm going to have a sip of water. 1 second. If C is opened and open is greater than 0, if C is closed and open is less than... Okay, so I think they did this within the same array. I kind of added it to... I really could have just used my count. That's a good way of doing that. Let's see if we can amend our solution here. Like maybe instead of... Like if count is 0 and P is that, we don't add this. So let's see, if indices add counts plus plus, else count minus minus. So if I'm ever adding an indices, like what if I were just to do, what if I did my result here? And here we did result.push I. Would this give us the same thing? Let me see. Got to give it some time so I can run the code. Looks like it worked. Okay, yeah. So about the same time percentage, I suppose. But yeah, this is nice because before we had this other loop that was also doing it at the end, which I guess is okay. Really, it's not. The time complexity is still the same. We're only ever traversing through this loop. Like even though we're doing it twice, that would give us 2 of n. But since we're dropping constants, we'd still have a linear time complexity. But obviously just having a loop once instead of 2 is still going to be faster. So something, nice little optimization that we were able to make there. So I'm pretty happy with that. All right, the next one is number of strings that appear as substrings in Word. So given an array of strings patterns and a string word, return the number of strings and patterns that exist as a substring in Word. A substring is a continuous sequence of characters within a string. ABC appears as a substring, BC appears as a substring, D does not appear as a substring. So are we trying to find, wait, number of strings and patterns that exist as a substring. Okay, so A does exist in A, ABC does exist, BC, D. Oh, interesting. Do they need to be, a substring is a contiguous sequence of characters within a string. So I don't think it's enough for me to just get frequency, because the frequency might tell me that there's enough characters, but not that they're necessarily in the same order. So explanation 2, A is in there, B is in there, and C is in there. But C is not in there. Now this one, there is an A. Like if there was a CBA, A would work, but ABC would not. So ABC needs to be in the same order. So it'd be nice if there was a BC appears as a substring and ABC. I don't want to go on a search every single time. Is there like, what's a nice way for me to create patterns. So really I'm looking for a pattern. Like, does this pattern exist in this other sort of piece of data? I guess like more generically, right? ABC. BC appears as a substring in ABC. D does not appear as a substring in ABC. 3 of the strings and patterns appear as a substring in Word. What's our upper bounds here? Patterns length is less than or equal to 100. Patterns I.length is less than or equal to 100. Consists of lowercase English letters. What if I stored all these inside, like I have A, B, C, and D, which could be marked as an array of 0 spots. So I guess this is almost like our frequency, but it's also easy to iterate, and we can maintain the order. Like I see here I have 1A, then I got 2 A's, 1B, 1C. I got another B and another C. Another C, and then 1D. What if like, oh wait, patterns inside of Word? Number of strings and patterns that exist as a substring in Word. ABC. So when I get to the A, I want to say, does A exist in A? When I get to BC, or ABC, does ABC exist in ABC? And why would that be true? You know what? I wonder if we can do some like crazy like bit set magic in here. Maybe. I don't know. I might be thinking like crazy talk here, but imagine we had some amount of bits and then ABC was represented by these least significant bits being turned on. Like this most right one for A, then B, then C. If I went to A and I just had this, like if I ANDed these together, would I just get the pattern back? Well, let me see. If I added this, I'd get the pattern back. Get the pattern back. And if we did D, right? If we did D, we would not get the pattern back. What if we had another one like A? Oh, but now this whole thing breaks because we have duplicates. So I should also account for duplicates. A exists in there and B exists in there. Can we come up with... I mean, we could do like brute force and just look for... Like if we're at A, we look here, we're at ABC, we traverse it, we're at BC, start traversing over this, and then we're at D. That's like one thing we could do. So it might not be the best, but at least it could be a way for us to start. As of this moment, I don't know of another maybe like better way of optimizing here. So I think I'll go for this sort of solution. So we have our patterns, and we have our word ABC. Anytime we see one of these letters inside of A, like if we see A, we go out, and then if we're out of bounds, we can just immediately exit. So I think that's fine. And if we ever exit, that means we've made it. So we see an A, we see a B, we see a C, I'm out. I see an A, I don't do anything. I see a B, I increment. See a C, I increment. Okay, cool. Go through A, B, C. If the index is not equal to the length, then we're good there. So let's do a couple things. Let's go through each one of the patterns. So for const pattern of patterns, let's see. And maybe just to be consistent here, I'll go ahead and do for let I equals 0, I less than patterns dot length I plus plus. I'll say const pattern is equal to patterns at I for let j equals 0, j less than pattern dot length j plus plus. Let's see. So now I'm going to want to go through my word, and anytime I see, I don't want to go through, right? I don't want to go, let's do this for const pattern. Let j equals 0 for let, I guess we'll have another one here. Maybe this should be pattern index for let j equals 0, j less than word dot length j plus plus. Okay, so if word at j is equal to pattern at pattern index, we'll do pattern index plus plus. If pattern index is greater than or equal to pattern dot length, then we can immediately add. We can break out of here and then add. So let num strings is equal to 0, num strings plus plus, and then break. Now let's kind of go through this real quick, right? So we have I is going to start here, right? And const pattern is going to be patterns at I, and our patterns index, I'll call it P, is going to be right underneath this A. Like this P represents this A. And then J less than word dot length. So if word at J equals pattern at pattern index, so patterns I, pattern index will increase pattern index. If pattern index is greater than or equal to pattern dot length, which it is, number of strings is 1. I'll just put a 1 up here. And then we break. Right? We break out of here. We start this. Now we go up here again. I is equal to 1. Pattern is equal to patterns at I. Okay, let j equals 0, j less than word dot length. If word j is equal to pattern at pattern index plus plus, increase j. Again, they're the same, pattern index plus plus. Increase the I, increase the j, or I stays the same, increase the j. They're both the same. This goes out. Now we go to the next I, where a pattern index is 0, and this is back at 0 here. Right? Hopefully some of you people on mobile can see this. If not, I know I see some more people have joined, so just a quick reminder that no need to worry. I do upload all these to YouTube afterwards, and you'll be able to watch this at your own pace. I can link up with some of you all afterwards to let you know where these videos are. So we get to the next one. Let's see if j0 equals, nope. So we go to the next j. Now they do equal. So increase this, increase j, they do equal, increase this. Cool, we can break. We get to the next one. This thing makes it all the way through the end. It never equaled and it never broke, so we never increased it. So I think this could be something that could work. Let's see, let's return num strings. So you get a 3 for the first one, which passes the first test case. Let's make sure we're doing plenty of test cases. 3, 2, 3, 3, 2, 3. So let's go ahead and submit this. Okay, so off by 1. That's unfortunate. So let's see where, I mean, this is a really, really long string here. So I guess I just missed. I'm guessing. Huh. Let's see. Where could it have gone wrong? So I'm kind of just looking for like the first instance of like, can we find a CF anywhere? Oh, that's not even what it has to be, right? It could be any of these, like DOJSF, DOJSF, okay, and then V. Let's think about this. If I start here at pattern index is 0, I get to the first V, pattern index goes out of bounds, okay. Go to HET. Oh, but you know what? I just realized something. My algorithm, it won't check for contiguous strings, right? Give me 1 second. There's going to be a little bit of noise. I'm going to put my desk on sitting mode because I'm standing up right now, but I'm getting a little bit tired. So just give me like a quick second. You'll probably, I wonder, actually, I'm going to try and mute this so you guys don't even hear that part. 1 second. Nice. I think that worked the way that it was supposed to, so that's kind of neat. First time using the mute button, doing it live here. Yeah, so I think what's happening is my algorithm is not, they need to be contiguous. So they all need to be next to each other. It can't just be that as long as these words exist in some order, it's going to pass here. Yeah. Let's see if we can use, I don't want to open this. I want to copy all this and see if I can just put it here on the screen. Got a really, like, we have a huge array here to deal with. It'd be nice if I can open this up. I'm going to try to open this up in Visual Studio. And I'm going to try and set up a different view so all of us can view this together. And it'd be nice if this, oh, okay, maybe I can make this const words. There you go. Okay, let me see if I can do that. If I add another window capture, oh, you know what? We can do window capture 1. Let's add another scene, VS Code. It's funny that I'm doing all this live. Give me 1 moment. Apologies for not seeing anything right now. We're getting close. Okay, we can do this, and then we can go to main. We'll remove this window capture. We'll set that equal to that. So that's LeetCode. This is VS Code. Okay, sweet. So I opened this up in VS Code because I think it's going to be a little easier for me to see. And I want a way to be able to keep this around. But I guess we can start from here. And what I'll do is after I look through each one of these, I'll like delete it from the array so I can just keep this with me at all times. So yeah, you see this right here, contiguous. So if I start, it can't just be, yeah, like anytime I find the start of one word, the next character, like they all have to be in order. So it could be something that as soon as I find a match, then we just keep going along until we find a substring. VRH, like VRH does not match, but K does. This one, I bet you it's, yeah, I think it's VRH. Oh, maybe this one too. Yep. That one matches. And probably one thing I'm doing is like if I do O, G, let's see. I have an O here. I have a G. Yeah, that's the only O I have. But with what I did, there's a way that it's not always going to check if they're contiguous. So I think what we can do is maybe, like for this one, I start counting. I get to a point where this is equal to the pattern index. I increase the next pattern index, and if it's not equal to 1, let's see. Go through my entire word. When I find the start of 1, maybe I can send it off. Let's think about this. What's a nice way to do this? I'm thinking of maybe creating a function that takes like a start index, and it can tell me if, for the given word, if I continue along, do all the characters match? But I also don't want to always be checking unnecessarily. Like if there's, if it's like JS, I don't want, if there's like 3 J's, I don't want to have to call that function 3 times. I mean, I'll exit early. We can also just, I think there's a, let me see, is substring no longer recommended. Oh, I don't even think there's, okay, there is no longer, there's no longer a method that tells you if that string is, oh, we can do includes. Again, is that the right way of doing it? I really don't think so. If I come back here, I mean, let's see something. That's not really my favorite way of doing it, but we could really just do, we can reduce this whole thing and say return patterns dot reduce, where we have our accumulator and our value. And what's this going to be? We start at 0. And here we say if value dot includes word, return ac plus 1, else return ac plus 0, which I guess we can just return ac. Wait, do I need to do this piece here? So this wouldn't work? Patterns, remember patterns dot reduce, and patterns that exist as a substring in Word. Oh, I think we need to do word dot includes value. Three, two, three, 3, 2, 3. Let's get this one right here. Is this going to be, okay, 3, 2, 19. It almost kind of seemed like the time limit exceeded on that one. Okay, so pretty slow. I'm almost certain this is not the way to go about this question. Here we're really relying on that method from the JavaScript library. Let's see what discussions have to say here. I'm very curious to know about this one. C++, no fancy O of NM solution. Ooh, with a try. Interesting. I was almost thinking about a try, but let's see. Well, okay, that's what they did here. They did the same thing. So construct a try, construct a tree by try and KMP, also known as Aho-Korosik algorithm. Then we can just traversal the word in one time, getting all the match patterns. It can support large patterns and a word. That's crazy. Medium, hard version. They should limit the constraints and leverage this problem, probably to a medium or hard version. return sum. So like what, I'm very curious, like what do you do? Note that find function in C++ is O of n plus m as it uses KPM. Again, this is one of those questions that's like, what does the interviewer want? Like, should I use the includes word? Let's see what they have in JavaScript. JavaScript direct way. Com++, index of. We could do includes nowadays. Right? Oh, if that's what, I'm not going to say like, well, I was almost going to say if that's what most people are doing, then I suppose it's okay. I'm okay with that answer. I think it's one of those things that, you ask your interviewer, you say, hey, I want to use find. I think it's a very direct and practical way of solving the question. Do you agree? And they say, yeah, then go for it. And again, these are marked as easy, so maybe that's the intent. Maybe the intent for a question like this is to figure out if you know the language even well enough to come up with that answer. Because it could be the case that someone that doesn't know the language that much would try to do it in a more complex way, and someone that does would do it in this sort of condensed version. So I'm going to refresh the page here. I want to see sort of where we stand. 53 questions. Pretty incredible. All right, so we have a lot of stuff here. Replace all digits with characters. You're given a 0 index string S that has lowercase English letters in its even indices and digits in its odd indices. There's a function shift cx where C is a character and X is a digit that returns the Xth character after C. Okay, so shift A1, C1, E1. Okay. Placed as follows, D plus 4. Okay. I think this is not too bad. I think it's going to rely on, first, we should definitely define that method, right? Const shift X is a digit. So we'll say car and then digit. That's where the magic happens, and we'll return something. And the nice thing is at the end, we can just map. I think we can come up with something that looks really nice here. A1, so shift A equals 1, B, B2, C3, D4, E. A, B, C, D, E, F. Oh, so A and then 1, then you put a B, D. I see. Okay. So anytime we see a number, that number is going to be replaced by, okay, yeah, that makes sense. Okay, so what do we do with this shift right here, right? That's really where the bulk of this is going to come. I think we're going to have to create an alphabet, but maybe not. Maybe we can do all this in line. So let's do a couple different things. We're going to have our digit and we're going to have our character. Okay. So I think here we can do const code equals string dot from car code. Let's see. No, we should get, yeah, const code is going to be car dot car code at 0 minus 97. So for that first A, we're getting 97 minus 97, which is 0, and then we add 1. Okay, and that 1, and then here we can say const shifted equals code plus digit. And here we should do modulo 26, because at the end we can return string from car code shifted, and here we'll do shifted plus 97 to get that one back. So let's see something. If we did Z, right, which would be 25, if we did like Z3, I would expect for it to be A, B, C, right? So let's do Z3. So 26 modulo 28. So do we not want to do, oh no, 28 modulo 26. 28 modulo 26, which would be 2, and that would be a C, which is exactly what we want, right? But if we have, let's kind of think of all this, right? We have Z, which let's go in the ASCII table. Let's look at all this. Where does Z fall into here? So lowercase z is 122, right? So if we get a code 122 minus 97, right? And then we do 25 plus 3 is 28, right? So I think this will give us what we want. And then we can just return that string. However, strings in JavaScript are immutable, so we're going to need to turn this into an array. So let's say copy equals s for let I equals 0, I less than copy dot length I plus plus. Here, if it's a digit, I think we can use, I think like a regex here would work out really nicely. So maybe we can do something like if, let's see. If I want to get that it's a digit, let's do this. Let's define a new regex called digit regex equals new regular expression. And this just takes a capture group. It's IG. I think we can just do this. I don't know. I feel like, I don't know why. I feel like this should be syntax highlighted some way. I feel like it doesn't like it too much what I'm doing here. But this digit regex, if digit regex dot test, the current thing that we're on, which is copy of I, right? So if, let's say copy of I equals a digit, which means that if we test that against our digit regex, that will be true. And then here we can say copy at I equals shift. We'll pass in the character, which is copy. I'm gonna sort of put this on two separate lines. The character will be copy of I minus 1. And then the digit, we'll need to parse this out. So copy at I, and it will pass in the radx. Shift I, and then at the end, let's try doing return copy dot join. So let me remove this. Let's run this code. A, B, C, D, E, F. Run the next one. Looks good to me. Let's submit it. Okay, 12.5. Let's see if we can. And I think something that we can do here, if we really, really want to be like, I mean, it's maybe not the best way of doing it. Can I just return a map of the copied thing? Like if I do return s dot map of my car, or let's say not car, but, or yeah, let's say car, because it could be, the character can still be a digit. Here, I can return, let's see, I'll still have my digit regex. So I'll copy this up here and I'll say return digit regex of digit regex test car. If this is true, then we should return shift, and here we can actually get the car and the index, right? So maybe here we can do shift of index minus 1 to get the car. Maybe here though, I think to make this a little bit easier, here we should do value here. If the value is a digit, we need to pass in the car car and the digit. The car is going to be the thing that existed in the previous index. So let me look at map here real quick. MDN map. No, not this one. Array prototype map. Right, we have element index and the original array. Right, so here we can do value index array. To get the car, we can go to array at index -1. And then here we can still do our parse int value of 10. So that, or we just return the value. And then here we'll just do a dot join. So let's look at this a little bit more closely here. So we're going to map over this array that we created by spreading the string. And we're going to map over it. We'll get the value, the index, and the array. The value is just going to be either a normal character, like a lowercase English character, or a number. So if this regex passes for the value, if it's a number, then we're going to shift. We need the character that comes before. So we have the original array, we have the index -1, and then we can parse the value at 10, or we can just return the current value. Let's see what this gives us. Looks like we get, at least from those two tests, we get the same thing. Let's run this. 63.36. That's funny. It's a, I guess it's a palindrome, right? It's spelled the same way forwards and backwards. 63.30. Yeah, interesting. So if I submit this again, 45.26. One more time. 73.28. Pretty happy with that. Let's see what discussion has to say. Simple replace. Literally did a simple replace. For auto S of I. Oh, well, they can also, yeah, they're able to, we don't have to create a copy or anything like that. S of I -0. S minus A plus S of I -0. Nice. I did a lot of math. Straightforward. Change a character to an integer. Shift CX is car CX in Java. Okay, so there's a built-in method for that. So maybe because JavaScript doesn't have these built-in methods. JavaScript simple solution from car code at, yeah. So it really is language dependent. Depending on the functionality of your language, what it can and can't do, your solution is going to change. You get some different mileage on that. All right, let me silence my phone. And let's see. So we're just over our hour mark. I wanted to keep this a little bit short. Well, not short. This is generally how I do these. We're at 54 questions, which is awesome. Very happy to see that. What I'm going to do is probably later today when I have another stream, I'll do a weekly roundup. We can just talk about stuff that's happened in the last week. And we can also maybe go over some of these questions that I had in one of my lists. These are just some questions I've sort of compiled. I would like to get back to them, so I think that'd be cool. And I might do that later today. I'm in Eastern time, so it's 5:45 p.m. I generally come on late. Like you'll see me around at like 10 p.m. That's very normal. So if you're still around, be sure to tune in. Again, for anyone that's watching now, I have been and I will continue to upload all of these videos to my YouTube channel. The YouTube channel is the best way to watch these streams at your own pace. And I have left an introduction there that tells you all about my intent and why I started doing this. I hope that this stream was way better than previous streams. I got the new microphone. I'm very happy with it. I'm eagerly awaiting uploading this to see if anything changes. I'm just excited to continue working with this new mic and having, delivering a better experience for you all. So I really hope that you all enjoyed it, and I hope to see you all around more often. If anyone wants, to link with me after this chat, feel free to hit me up on Reddit. I normally respond to chat messages really fast. If you want more information, I'm always down to talk. Else, have a nice rest of your day, and you'll probably see me again in chat and in stream very soon. Later, guys.